Okay, good morning everyone. Today we'll finish up 11.5. I just have one thing to talk to you about, and that's outliers of data sets. So an outlier is an extreme value that is much less or much greater than the other data values. Outliers have a strong effect on the mean and standard deviation. If we find that an outlier is a result of measurement error or represents data from the wrong population, we usually remove it. There are different ways to determine whether a value is an outlier. One way is to look at data values that are more than 3 standard deviations from the mean. In other words, we take our mean or average or x bar and then we add 3 times the standard deviation. Remember, this is sigma x, so that's our standard deviation. Or we take our mean x bar and we subtract 3 times our standard deviation. And if we find values in our data set that are more than 3 standard deviations away from the mean, then we consider those outliers. So here's an example. Find the mean and standard deviation for the height of 15 cans, and let's identify any outliers. So this data was entered into our calculator, and we generated some statistics. Okay, we see that our mean x bar is 92.77, and then the standard deviation sigma x is 0.194. And again, ignore the sample standard deviation. We don't use that in Algebra 2. All right, so we have our mean and we have our standard deviation. Now let's determine if any of these values represent outliers, which would be more than 3 standard deviations from the mean. Okay, so identify the outliers. Look for the data values that are more than 3 standard deviations from the mean in either direction. 3 standard deviations is about 3 times 0.195 equals 0.585. Okay, so we take our mean and we add 3 times our standard deviation. Okay, they said 0.195 rather than 0.194. So let me erase this, be consistent. So the mean, 92.77, plus 3 times the standard deviation gave us 93.355. And then 92.77, our mean, minus 3 times the standard deviation gave 92.185. And now let's take a look at our data and see if we find any values that are more than 93.355 or any values that are less than 92.185. Values less than 92.185 and greater than 93.355 are outliers. So we do have an outlier, 92.1, which is less than 92.185. So 92.1 will be considered an outlier. So that would be an outlier. More examples here. Here in 2003 and 2004, the American League Championship Series baseball, the New York Yankees scored the following numbers of runs against the Boston Red Sox. The New York Yankees were a great baseball team during those years. So, okay, so they had runs of 264, 24, 66, 10, 3, 19. Wow, that's like a football score. And then 4, 4, 2, 3. Identify any outliers. Okay, so again, we ran statistics with our calculator. We got a mean of 5.35 and a standard deviation of 4.32. Okay, so outliers look for the data values that are more than 3 standard deviations. So if I take 3 times 4.3, okay, so that would be 12.9. So we take our mean, 5.4, and I add it to that 5.4 plus 3 times 4.32, or 4.3, and then that gave us 18.3. And then 5.4, our mean, minus 3 times the standard deviation, minus 3 times 4.32. And that would give you negative 7.5. So let's see here. So 19, if we go back up, 19 was an outlier. It was more than 3 standard deviations away. 19 was greater than 18.3. Here's interesting. So this was the result of the homework quiz from 2 classes. I'm not saying which class is which, but in one class this was the box plot, and box plots are nice in comparing like performance against various categories. Okay, like between classes here. So I want you to notice there's a lot of variability in Class A versus Class B. And Class B seemed to they did much better on that homework quiz. But anyway, the Class A had an average of 7.06 and a standard deviation of 4.12. Class B had an average of 10.2 and a standard deviation of 3.41. So let's identify any outliers in Class A or Class B. So Class A outliers, we would take the mean of 7.06 and we would add to that 3 times the standard deviation, and that would be 19.42. And then 7.06 minus 3 times the standard deviation, that would give you negative 5.3. So there were no outliers. Okay, so the scores went from 1 to 13. No outliers in Class A. And then let's look at Class B here. So again, their mean was 10.2. So we take 10.2 times 3 times the standard deviation. That would give us 20.43. And then 10.2, the mean, minus 3 times the standard deviation. And that would give us negative 0.03. So again, no outliers in Class B. Okay, because it went from 3 to 13. Actually, the max was the 3rd quartile. A lot of students got 13 in that class. All right, but there were no outliers. So that's how we determine the outliers. We take the mean and we add 3 standard deviations and the mean minus 3 standard deviations. And if we have a data value that falls outside that range, then those are considered outliers.